Hello, everyone. Thank you for coming to our session today about our MARA project, our Modern Applications Reference Architecture. My name is Damian Curry, and I'm joined by Jason Schmidt. We're part of the Community and Alliances team at NGINX. So let's just get jumped right into it. So first of all, who are we? So we're the Community and Alliances team at NGINX. Our two primary roles are working with the OSS community for NGINX, as well as working with partners. Unsurprisingly, a lot of those two have a lot of overlap, where a lot of our partners are also open source community members and other companies that have open source projects as well. And as far as what are our backgrounds, we have a very diverse background when it comes to our team. We have mostly have people who have spent some time in operations, development. We've done time in QA and change management. Basically anything you can think of, one of us has probably done it over the years. So it really has been a great benefit to us when it comes to working on this project, because it does have such a wide reach. So I guess the next thing is, what are we really talking about today, and why did we build this? So the primary thing when we started looking at building this reference architecture is we wanted to provide a pattern for how to deploy and manage modern applications to act as an example, so that when we were talking about this idea of a modern application or a modern application architecture, we were able to actually have something tangible that we were able to show how these ideas can add to the scalability, portability, resiliency, and agility of your applications and architectures. We also wanted to respond to a lot of the existing anti-patterns that our team has seen around in our past. You have all these reference architectures and they look really interesting, and you click on them and you read a blog post and there's a bunch of pretty diagrams, but that's where it ends. Or you'd have these situations where they're just toy applications. They're very basic, very cookie cutter, and can show you, for example, how to deploy something on Kubernetes, but it's not a really accurate example of what a production application would look like. Also, obviously the most hated one, probably the marketing materials that are very vaguely masquerading as technical examples. So there's a lot of, all the keywords are there to get the Google search results and all of that. But when you actually get to it, there's really no technical details or in-depth working. And probably the last one that is the worst for a lot of it is non-reproducible examples. You see a ton of marketing material or sales pitches with these finely polished demos and example applications and architectures, but they're not easy to build, and they're not easy to actually, you usually can't get your hands on them and actually work with the code and see what's actually working under the covers. And the last part, and is probably the part that's most important to all of us, is looking at and wanting to highlight the open source part as core of the modern applications. We wanted to have this to be shareable code, to put it back out there so that hopefully, we don't expect people to come across all of our code that we've used to build this reference architecture and pick it up and drop it into production. But we hope that somebody will go, oh, that's how you automate, EKS stand-up, or, oh, that's how you fix that one problem, and be able to take that code and take it and tweak it into what works for their application and for their specific environment. So now with that done, let's start getting into here. Jason, I know I've been talking too much. Why don't you jump in here and actually go over some of the details on how this works?
No worries. Thank you, Damian. So as Damian said, this is something that with all of our experience, we obviously feel pretty strongly about, especially the open source component. And when we sat down to work on this, one thing we wanted to do, kind of driven by those of us from the ops background, is to separate things out. We're going to have an infrastructure, we're going to have Kubernetes, and then on top of that, we're going to have our management, our application, and our observability. And we want this all to be able to be automated with infrastructure as code. And it's important for us to allow components to be swapped out or removed. A lot of times we put we tend to put things into production, or at least, hopefully not into production directly, but we test and we're like, this is easy to stand up. We're going to go with it. And that may not be the best decision. And nothing is worse than painting yourself into a corner and realizing a year in that you made a pretty major mistake in what you chose. So we wanted to show a way of how we could swap a piece out. So for example, if the logging decisions we make today, 6 months from now, don't look as good, we want to be able to easily swap that out. And this is, go ahead, Damian.
Oh, I was going to say, and I think really this is one of the pieces that is, most important is it's that idea that you're not stuck with your decisions, right? Because I'm sure we've all experienced that in our operational background where you're like, wait, why are we doing it this way? It's like, well, there used to be this guy who worked here and they made this decision and now we've still got it. And it's really nice to be able to kind of step back and look at it and go, okay, we're using this framework, right? There's lots of different tools that get you to the same endpoint, and it's good to be able to, show and keep in mind that you can swap them out, right?
Yeah, and swapping them out and being able to test them. And the way we've built this, you can run this on a workstation, you can run this in EKS, you can run this on Rancher, you can run this anywhere. So as a proof of concept, I can run it the current way and I can run it the new way. I can do my benchmarking. And then when I go to the meeting to discuss it, I have actual data to back myself up and say, look, we really need to give this a chance. And I guess the final thing here is restricting the scope of changes. We've all learned, most of us the hard way, that making multiple changes is never a good idea. So if we restrict down to here, I'm just changing the telemetry observability, I'm just changing the logging, that reduces the blast radius of any change that you make that may go south. So what's in the box? What have we put in? So for the infrastructure, the Mara project will run against any Kubernetes distribution you have a kube config file for. If you can talk to it via kube control, you can talk to it through Mara. We've also provided detailed scripts that will go through and stand up infrastructure in AWS, Linode, and DigitalOcean. So with AWS, it goes out, it sets up a VPC, it sets up Elastic Kubernetes service. With DigitalOcean, it sets up their DigitalOcean's managed Kubernetes. The same thing with Linode. So we can set up your infrastructure. And once that's set up, we go ahead and drop observability in. So for tracing, we've put the Open Telemetry operator in place, and we use that to spin up a collector. For metrics, we have a Prometheus instance out there. Logging, we're currently using the Elastic Stack, but this is an area we're looking at some of those changes. Like we're looking at some of the things that Elastic has done. We're also looking at perhaps Grafana Loki in this place, and there's a few other competitors in this space we want to try and see what works best. And then for visualization, right now we have Grafana. And then our management level, we're using Cert Manager for management. We do have some work that has been done around using the Acme certificate Let's Encrypt. That's not in the mainline code right now, but something we're very interested in bringing into Mara in a more mainstream fashion. For secrets management, we're using Pulumi. And I'm going to jump ahead a couple bullet points. So we talked about how our infrastructure as code was important, and what we've chosen for that is Pulumi. And one of the big drivers behind that was being able to write our code in Python. Pulumi supports a number of languages, but when we looked at them, Python we felt had the broadest appeal and would be the easiest for people to figure out, even if they were not Python programmers. So we use Pulumi as infrastructure as code. Pulumi also has its own secret store, so we store secrets in Pulumi. We're also looking at leveraging Kubernetes secrets for this. And then a part we're keenly interested in are Ingress, and we have it set up to use the NGINX Ingress Controller. You could also use our subscription NGINX Plus Ingress Controller, but you don't need to. You can use the open source version, and we built everything to use open source where possible. Our application is what we call the Bank of Sirius, which is a fork of the Google Bank of Anthos code. And it's been heavily modified. Some of the modifications were to work within our deployment. And some of the modifications actually were put in as we added open telemetry. And we have some blog posts out there on the NGINX website talking about the struggles we had adding open telemetry to an existing application. And this was one of our first internal validations of Mara as a good tool, because we were able to go ahead and use it to test upgrading an application. Because we all have had that experience where somebody from management comes and says, we need to put this in. How do you, go do it? So we did that for everybody. We took the pain of putting open telemetry into an existing application and wrote about it. And you can read about it. You can look at the repo and see how it works. You can open issues or ask questions in GitHub discussions. We're happy to share this knowledge. And then finally, continuous integration. There's a lot of players in this space, but the biggest and one that's been around the longest is Jenkins, which also happened to be the one that I knew best. So I have set up Jenkins to do test deployments against all our supported infrastructures. This is another area where we want to look at bringing some other tools into play. Damian, anything I'm missing here?
No, I think you covered the one thing, and that's kind of the down the road as we talk about, and we've got all these different pieces that you move in and out, and talking about the benchmarking. Obviously we're NGINX, so we want to highlight our ingress controllers. But one of the other things we want to kind of do down the line as this matures is be able to use different ingress controllers and be able to do benchmarking against it, so that if we do say like, hey, we're the best, right? If we're going to say our ingress controller is better for these reasons, we want to be able to have the numbers to back them up. So that's one of the other things that we really wanted to highlight here, is being able to show off not just our own stuff, but highlight, partners, competitors, other people in the community, and actually have a baseline repeatable deployment scenario, because that's, in my mind, usually the hardest thing is to how can you compare these different deployment scenarios when they're so drastically different and try to claim performance benefits. So it's really interesting to be able to make these changes, redeploy it, and actually, have good data to look at.
Oh, that's a great point. And one thing we haven't included in this presentation that I'm excited about, I think most of us are, is we have a project coming along called Project Cicada. And Cicada is built in order to do load testing and enable you to go ahead and do benchmarks against given values. So that benchmarking that Damian talked about is something we're very interested in. And it goes back to something, a lot of us learned early on. If you want to be the best, you have to play against the best. So although we are predisposed towards our own Ingress controller, service mesh, what have you, we want to see how the others perform. We think it's important. And I think it's important for everybody going to, the rising tide lifts all boats school of thought, which is a big part of open source for me.
Yeah, definitely. There's never one right answer. It's what's right for what you're trying to accomplish. So being able to provide that flexibility and just be able to highlight too, just there's a lot of stuff that goes on in these environments, and this is the kind of the way we think about it, this is kind of the bare minimum, right? There's probably a few different things that we're missing in the mix here, but this is just kind of like, hey, if you're going to be running an application, this is the stuff you need to run before you even start looking at application code.
Yeah, no, I mean, that's so true. It's like an iceberg. The application sits on top, but there's a lot underneath going on.
Yeah.
So where can I run Mara? We've talked about this a bit, but you can run it in the cloud. A couple of these cloud providers, like I mentioned, we will set up the infrastructure for you. A couple of them you need to set up yourself and just feed the kubeconfig into Mara and it'll run. Locally, we run against MicroK8S, we run against Minikube, we run on K3S, we run on RKE, we run on RKE2. These are all things that we test as part of our release process, so we know that they work. And then, anywhere, if you can run against anything that has kubeconfig, if it's a compliant distribution, it should work. There are two requirements, and that is you have persistent volume support, and that you have the ability to assign an egress IP, what Kubernetes refers to as a load balancer. If you can do that, then you can run Mara.
Yeah, and I think this was really one of the key points, is wanting to be able to separate the different chunks as we do these deployments for the reference architecture. It's great if you have nothing and you're just like, oh, this looks like a fun toy, maybe I should play with that. Cool, just run the script and it will set it all up. But then say if you do want to have that, like, oh, this actually makes sense for my environment, we've been trying to be really specific about making sure all of these different steps are separate and can be pulled out completely and operate on their own without requirements of all of the other ones.
No, that's very true. And again, watch our blog for some discussions on places where things were connected that we didn't think were connected.
Yeah, you always find those ones the hard way.
So who runs Mara? Obviously we do it internally, and that's something that we use in our day job, so to speak. But we want to put together some sample use cases here. For a developer, I just want to stand up my application. This is constructed in such a way that you should be able to look at the code, look at the application code for Bank of Sirius, and swap your application in, and it should work. If I'm an operator, how do I manage, monitor, deploy, and support that application? What's it look like? What are other people doing? What are some of the best practices? And that's something we can do as operators. QA engineers, Damian's mentioned this already, a reproducible test environment. I want to stand this up and benchmark it. And that's where Project Cicada comes in. Once that hits, then we can go ahead and cycle through that. QA engineers are really big on repeating things time and time again, and we want to make that as easy as possible. And then startups. If you're a startup in the space that does telemetry or does metrics or does logging, take the piece that's in there out, put your piece in. That accelerates your development and helps you get to the point where you can go ahead and just let it go and show people.
Yeah, and even beyond just startups, I mean, we've actually Sumo Logic was the first partner who built an integration so that you could, you deploy Mara, set a flag, and then instead of deploying, things into the cluster, it just configures it to send it offsite. So we really, anybody who wants to highlight different code in here, it's really nice. That's one of the things we wanted it to be, an open source, framework, right? And so that anybody can take it and leverage what we've built to show off your own product, right? It's we hope that people will do that.
So how do I run Mara? Well, you can head over to nginx.com/Mara. We have a vanity URL that's set up to redirect you to our GitHub repository, or you can go to the actual GitHub repository under the NGINX Inc. account. You might notice that the URL for the repository and the repository name is Kick Reference Architectures. This has to do with the original name of the project and the original purpose of the project, which was just a way to deploy and build our Ingress controller. And from there, we kind of crept a bit until we have what we have now, because as we worked on this, we discovered that a lot of this stuff that we thought was out there wasn't there, so we decided to build it ourselves. Once you've gone to the GitHub repository, clone it, and then you're going to require a K8 installation. If you don't have that, you need credentials for a supported cloud. There is a Getting Started guide linked from the main page, and if you have questions, you can look at that. That also links to some additional documents, including what are our tested architectures, what are some of the known issues, and from there, you're also able to raise issues or engage us in discussions if you're having problems. Once you have that, the repo and your credentials or your K8 installation, you set up your virtual environment, which downloads all the necessary dependencies and code. And then you run the start.sh script, which will walk you through a number of prompts that set up everything. And then you sit and wait for the process to complete. And at that point, you'll be up and running Mara. Finally, one thing that I wanted to touch on, because this has greatly simplified my life, is the Harvester project. As we were going through and we're contributing to the Mara project, testing became important. And we need to test not only against clouds, but also against these workstation distributions like Minikube, Micro K8, K3S, RKE, and we needed to find an easy way to do that. And I had used some other virtualization tooling, and then somebody introduced me to Harvester. And I had been a Rancher user before, so the interface was familiar, and it hit these requirements here. I wanted something easy to orchestrate, easy to clean up, that I could automate. And basically, I didn't want to be the system administrator of my virtualization solution. I wanted it to be a tool that I could use. And Harvester fit the bill. I can set up via Rancher as the Harvester provider. I can set up K3S and RKE and RKE2 clusters, test against them, destroy them. I can set up virtual machines that I then go into and deploy things like Canonical's Micro K8S. And I can also use it for other work that I do that's non-Mara based, testing things, deploying things, building images. So Harvester has been a big part of the Mara story to get it to this point. And it's something we're looking to use and integrate a bit more tightly through the Pulumi Harvester and Rancher providers as we go forward.
Yeah, it's a really, really powerful, and another layer of to obscure away what's underneath, and it really does help. Whether so you don't have to always be developing in AWS or something like that.
Yeah, and there also is the cost part of it, because we're extremely fortunate in that we have a decent budget for doing work on clouds. I have worked in startups where that's not the case. So this is a way that you can use, like we did, some commodity machines and get a great environment together.
Yeah, and that was definitely something that was a response to the community when we first announced that we were working on this project. In some of the early stages that only had support for EKS, we were getting people going, "This is awesome, but EKS is not cheap. Like, can you support something else?" So that's when we started looking at that DigitalOcean and Linode, because those are kind of those clouds where we run things in our spare time for not work purposes. So we really wanted to make sure we highlighted them as well.
Yeah. So at this point, we are ready to go into our demo, where we're going to show what it looks like to deploy Mara on a fresh VM running in Harvester. And we're going to go ahead and go from the start, where we check what the system has in terms of resources, and we go through, and at the other end, we wind up with a running Mara installation. So the first thing we want to do when we're setting up Mara is we want to check the operating system, just to make sure that we have the resources necessary to run Mara. You can use whatever method you want here. There's probably at least 15 different ways to do it. What I like to do is use LS hardware. I can see we have 4 cores, we have 24 gig of memory, and we have enough disk. Now we're going to go through and install Docker, make, which if I could type, and the Python virtual environment.
I almost think you'd done this before. But honestly, it's the little things like we really want to make sure we document how much those requirements were, because I can't tell you the amount of times I've spent going, "Oh, okay, this will run." And then you find all these weird errors and you're like, "Oh, I need more disk." You go back and fix it, and you run it again. You go, "Wait, what's this error from?"
Yeah. And K3S is a dream to install versus some of the other. It's a single binary, and we installed it. We copied the kubeconfig. We're going to go look at the cluster info. We're going to go ahead and get a more detailed view. And you'll notice in our Mara scripts, we actually kick this information out too for debugging, but gives me both client and server information. And K3S is running. Clone the repo, init the submodule, which is our bank of serious source code. And here's what we're talking about, the virtual environment. When we set this up, this installs all the necessary tools at the right version. So it'll install Pulumi, it'll install kube control, because one of the things you'll notice with Kubernetes is you'll get version mismatches between client and server. We don't like that, so we install our own version. Go ahead.
The thing that I really love about this too is it's all done in a virtual environment. So you can run this locally and not destroy your own development environment, which I know I've done countless times.
Yeah. I mean, we'll be honest, we didn't start out with a virtual environment, I don't think. So,
Yeah, we learned that one the hard way too.
anyways, see at the very end, we're downloading Kube Control, we're downloading Pulumi, and now we're on to Mara. And here's that start script. And it's going to ask you for a Pulumi token. It's going to ask you where your kube config file is. And it's going to ask what you want to call your stack. It walks you through all of this. This is very simple to do. Pay attention to the information scrolling by. It is a bit important. Out of the box, it's going to install the vanilla NGINX Ingress Controller. If you have a Plus subscription, you can add a JWT in there, which will allow you to pull Plus. It is going to build certs, so you do need a host name. You need a host name that actually resolves back to that IP. And then once it collects that information, it goes ahead and gets started here. And you see it downloading its plugins. It sets itself up. And then this is the modularity we talked about. This is the Ingress controller being deployed. And Kubernetes is going ahead and spinning up all these pods and services. Pulumi is telling you what it's trying to do. If there's a failure at this point, Pulumi makes very clear what failed. And then you can either go ahead and look at the log files, you can go to the Pulumi website and see what failed.
Yeah. And one thing that I know we're not leveraging in this specific demo that we definitely don't want to gloss over is that all the code is here to do custom builds of the Ingress controller container image as well. So if you want to have that, if you have requirements for your own images and what base image they use or things like that, we wanted to be able to have and show people how that's possible as well.
Yeah, and that was one of the drivers behind using Pulumi, and the driver behind why it's called the Kick reference architecture.
Yeah,
because we got tired of building our own images and pushing them. Like, we wanted a simple way to do it, because we figured if we were getting tired of it, then the community probably was too. So it allows you to build, it allows you to pull directly, it allows you to add layers to the Docker container image, push it back up. There's a lot of options there, and you can read more about these in both the README files and in the configuration file, where we show you how to change these things around.
Yeah, and I know we have a few different blog posts as well on NGINX that go over in more detail some of the different deployment scenarios, as well as the OTel stuff we were talking about before. And I'm sure there'll be more to come as we really want to highlight some of the different pieces that when you look at the deployment process here, it kind of glosses over, but there's a lot more complexity that we found as we were going down this path than we initially had any idea of. So it's been a great learning experience for us as well. And we're just really hoping that it helps other people out there in their own Kubernetes journey. Yeah.
And there's, like most of these modules, there's a story behind it. And, right now we're deploying the log store, which is the Elastic Stack. And we did discover that Elastic Stack can be very resource hungry, even just, with the small amount of data we're pushing to it. So this is what kind of kicked us down the path of maybe we should look at another logging solution.
Mm-hmm. Well, and then that it also kicked off a conversation that we're trying not to go down it yet, but the idea of like, okay, well, when do you start building a application cluster and a management cluster, right? At what point does it make more sense to separate out these pieces? And because I know in my past, that's something we've definitely run into where, you have for example, a log store out there, and then somebody goes, oh, okay, well, I'll just ship logs there, and I'll ship logs there, and I'll ship logs there, and then all of a sudden everything grinds to a halt. And it's really interesting to be able to approach it in this way.
Yeah, I think we've all had that experience of I'm just going to put this out there for now, and then 3.5 years later, that's a load bearing part of your system. So by making these modules in such a way that you can swap them in and swap them out, that was our hedge against painting ourselves into the corner.
Yeah, and it is interesting as we've gone down and had the internal conversations about how we do this. It's it's not straightforward. Like we've had some long conversations about, why don't we just break out into our own clusters and we'll do this. But then it's like, okay, now we're getting too complex. And, you can tell that a lot of us have run production environments before, and we're all have been woken up at 4 a.m. too many times because, exactly like that, something that somebody stood up years ago and basically forgot about actually just took out the production site, right? So.
Yeah, and it's interesting, and it exposes some of that inherent tension between those of us who came up on the operations side and those of us who came up on the application side, because we take very, very different approaches, and we all want the same thing. We want this to be a great user experience. We just have very different ways of coming at it.
Yeah.
So it went through and installed the log agent, and now we're setting up cert management. Cert Manager installs a whole bunch of CRDs, or custom resource definitions, for the cluster. These are really the glue within Kubernetes in general, but Mara utilizes these a lot. And it's something that we want to look further into as we move along. Like what is the next incarnation of Mara going to look like?
Yeah. And we have actually been working. We just released some support in our Ingress Controller implementation to extend some of the support for Cert Manager. So we'll definitely be adding functionality as more stuff comes in there, which is part of the fun, right? We get as soon as you think you're done with it, you're like, oh, wait, we started supporting this new thing over there. So now let's go bake that in, and let's see if we can make our lives easier or more complicated by trying to use it.
Yeah. And for me, that's been one of the great things about Mara is that we do try and come close to what a production application would look like, what a production environment would look like. We don't have any of the production SLAs or constraints, so we can blow the whole thing up and install the neat new thing.
It has been kind of fun for that, because it's almost like when we were building production environments, except without all those pesky deliverables and time frame and outages. So it's really been a fun experience of just kind of going, okay, in a perfect world, and we get to kind of create that, I don't want to say a perfect world, but we get to kind of start building that vision of how we think it should be done, or how it is easily, maintainable, and just all that fun stuff.
Yeah, and what would be great for us is to hear from other people who've had different experiences with these tools, be them Mara or not. If you have a strong opinion, do let us know. We are very well aware that our decisions are probably not the best, and we are really keen to hear other points of view and how other people have approached this.
Yeah, which is one of the main reasons why, from the beginning, you can go back and look at the Git history, right? We've been building this in the open, and we really want that community input to come in and tell us where we did something wrong, or, give an idea of a different way to do something. And we really just want it to be, out in the open and just there for everybody to be able to weigh in on, pick apart, tell us what we did wrong.
Yeah. And you're saying that right as the open telemetry stuff is going on. And open telemetry, another member of our team, Elijah, spent like 3 years in the course of 2 weeks doing open telemetry. And it was painful. It was difficult, but, I think we're happy with where it wound up, and a good way to show, some of the trade-offs we've had to accept, and some of the open telemetry stuff is not as mature as we hoped it would be.
Yeah, and I think that's one of the other things we really want to highlight is the idea of using, instead of using products in it, we want to use protocols or standards, and have that, so you have that modularity. Because like we said, all these decisions that we're making are based on our past experiences and our opinions, but we know we're not right. We know that there's other opinions and other thoughts out there, and we really want to hear those.
Yeah, that's a huge part of it.
Well, it looks like we got to the end here. So now you end up with an IP address and a FQDN, and you're all set.
Yeah, and so at this point in time, you set up that IP address to resolve, and you can do this using host, DNS mask. If you have your own DNS server, you can obviously do that. Whatever way you need to make that resolve. And then when you go hit that IP, you will get the login screen for the Bank of Sirius. And then if you want to go ahead and access the management tooling, there's a simple program out there. It's the world's laziest script, but it'll go ahead and set up kube proxy tunnels for you to access Kibana, to access Elasticsearch directly, Prometheus, Grafana, and the Locust load balancer. So you can go in, you can dial up a load on Locust and see how that responds in your cluster. The port forwarding can be a bit tricky if you're doing this somewhere other than on a local workstation. There is a document out there that explains some of the tricks and tips around doing that if you need more help. Beyond that, again, feel free to raise an issue or mention something in the discussions tab in the GitHub repo. And then there's a few extra notes here is how you can dump the configurations out, how you can re-get the load balancer IP if you lose it. And then, number 3, how to explore the deployment. A tool that I use a lot is Derailed's K9S curses-based Kubernetes tool. It adheres to most of the kube control type commands, but it's a text-based interface that I personally find a lot easier.
Yeah. All right. Well, yeah, thanks everybody for joining us today. And yeah, like we said, please, come check us out. Tell us what we did wrong. Give us some suggestions, and yeah, join in on the fun. And hopefully everybody enjoyed this. And yeah, thanks again.
Thank you.